Lesson 9.2b, Finding the Roots and Vertex. Essential question, how can I identify the roots, vertex, and y-intercepts given quadratic equations written in various forms? How can I find the vertex of a parabola from knowing its x-intercepts? And how can I write a quadratic function given its graph or features? So far, we have looked at a lot of different vocab words, and so we have them all written in this box up here, along with our three different types of equations. And so we've got a couple fill-in-the-blank problems below that we will go through using our word bank. The first fill-in-the-blank question says, the blank are the x-intercepts. We know that the word roots is the same thing as the x-intercept. The blank form is blank. The type of equation that uses roots is called the factored form, and that is y equals a times x minus r1 times x minus r2. The blank is the center of the graph. The vertex is the center of the graph. This is often referred to as the maximum or minimum of the graph. The vertex form is y equals a times x minus h squared plus k. The blank form is used in projectile application. The general form is used in projectile application. The equation is y equals ax squared plus bx plus c. The equation solves for the height of the projectile based on the amount of time since launch. This fill-in-the-blank section is going to be a great tool for you guys to use since it breaks all three of those different forms up into telling you really when you'll use them. So I'm going to make a big star over here even just so you know that that's a great thing for you guys to have written down. Example A, given that y equals x minus 3 times x plus 9, can I find the vertex and how? This is just like the very last problem we did in yesterday's notes that we just kind of briefly looked at. So over on the left side, I'm going to write a few steps that you can follow to find the vertex given factored form. First, go find your roots. So if we're in factored form, remember this really tells us that this is r1 and r2. So we already know we have a root at 3, 0 and at negative 9, 0. Remember, they really just change signs. If you were ever unsure, remember you can also take that x minus 3 and set it equal to 0, and also the x plus 9 and set that equal to 0, and then solve. So then you should get that x equals 3, and subtracting the 9, you'd get that x equals negative 9. So either way, you should find 3 and negative 9 as your roots. Step 2, find the x value of your vertex by adding your roots together and dividing them by 2. So our roots we have are 3 and negative 9, so 3 plus the negative 9, and then we're dividing that by 2, which would be negative 6 divided by 2, or negative 3. So now we know that for our vertex, our x value would be negative 3. Our last step is to plug our x in to find the y value. So now we know our x value is negative 3. So in our original equation, into this factored form, I'm going to plug negative 3 in for x. So we still have y equals, but our x is now becoming a negative 3, and then the minus 3 is still there, and the other x also becomes a negative 3. And then we just calculate this out. And so we'd have that becoming negative 6 times 6, which equals negative 36. So our y value in our vertex is negative 36. So now we know that our vertex is negative 3, negative 36. What are 4 things that we pay attention to in a quadratic equation or graph? We have the roots, we have our vertex, we have our y-intercept, and lastly we have our line of symmetry. Example B, solve the following equations for x. I'm just going to do a few of these, I'm not going to do all of them. There are a lot of examples though, so this would be a good section for you to go back and practice on your own after we are done with notes. So this is really looking back to a couple chapters ago when we looked at quadratic equations and how to solve those. So in example A, we have x squared equals 15. Now we want to get rid of that squared because we want x to be alone. And so remember we talked about how squaring something is the opposite of square rooting it. So if we wanted to cancel out the squared, then we want to take the square root of that x squared to cancel them out. But whatever we do to one side of our equal sign, we always have to do the same to the other. And so remember, once we square root something, we have 2 different possibilities for our answer. So we really split it apart. And so the square root of x, squared and squared are just going to cancel out. So we're just left with x equals, And then on the other side, we want to take the square root of 15. It is not a perfect square, and so if you put in your calculator, it's going to come out to be about 3.9 if I round that up a little bit. And so we'd have a positive 3.9 and a negative 3.9. So remember, when you square root something, your answer is always one positive and one negative version of that number. I'm going to skip over to example C and solve that. And so before we can square root anything, remember we have to solve for just the x squared first. So subtract the 5 to the other side, and we have 2x squared equals 6. And then dividing by 2, since the x squared is still not completely alone yet, then we'd be left with x squared equals 3. Now we can square root to get rid of those x squared. And so now we want to split into our two different equations where we have x equals, and the square root of 3 is about 1.7. And so I'll put a positive 1.7 for one answer and a negative 1.7 for the other answer. I'm going to jump down here to example D, and that'll be the last one we'll try on this type of problem. So this time we have x plus 2 squared minus 8 equals 41. So before we can square root anything, we do have this squared in the exponent here, and so we will want to square root eventually, but we have to get rid of anything on the outside of that squared first. So we have this minus 8 on the outside, so let's go ahead and add 8 to the other side to get rid of that. And so now we're just left with x plus 2 squared equals 49. Now that squared is on the outside, and that's the only thing that's on the outside. Everything on the inside we'll want to wait on. But to get rid of that squared, remember, square root is the opposite of squaring something. So take the square root of both sides, and then that squared and the square root will cancel. Make sure you split it into two equations before you write it out. And so we're going to be just left with x plus 2 on the left side. And then the square root of 49 is 7. So we should have one of those be a positive 7 and one be a negative 7. Now we're not done on this one yet because we still have x plus 2. It's not completely alone yet. So make sure you go back and solve that for x. So you should be left with x equals 5 for one answer. And then subtracting 2 on the other side, we would have that x equals negative 9. The last problem is example C and example D. It says find the roots of each equation below. We're just going to focus only on A, and then part D is going to ask us what the vertex is of, and we're just going to again focus on example A. So the roots always come from just taking our parentheses and setting them equal to 0, and then solving them each for x. And so subtracting 2 from the first one, we would get x equal negative 2, and that makes one of our roots as negative 2, 0. And then adding 4 on the other one, we would have x to equal 4, which means our other root is at 4, 0. Example D asks us what the vertex is, and so we did this on the front side of our paper. So we take each root, negative 2 and 4, and we add them together and then divide them by 2. And that's going to give us the x value of our vertex. And so we find our x value to be 1. So now that we have the x value of our vertex, we want to go back into the original equation and plug 1 in anywhere we see an x. And so just simplifying that equation, we'd have y equals 3 times negative 3, which would equal negative 9. So we know our y value of the vertex is at negative 9, which makes our vertex at the point 1, negative 9.